So let's go ahead and begin. Code today is QRD UHC. For the bell work today, give it a circular blade on a saw, rotating at 2,400 revolutions per minute. What I need you to do is find the angular speed in radians per minute. So basically, you need to convert from revolutions per minute to radians per minute. I'll give you 3 minutes to try that out, and then we'll go over it. So if I want to convert 2,400 revolutions per minute, per 1 minute, I'm going to multiply by a conversion rate. And my goal is to have my answer be some amount of radians per 1 minute. All right, so what I need from you, Lily, is in one complete revolution around a circle. First, tell me how many degrees would that be for a full revolution around a circle?
Like 360, right?
That's exactly right. Very good. Okay, and then do you know how many that would be in radians then?
Oh man, I'm not sure.
Yeah, that's okay. That's fine. That was the new stuff we did Wednesday. Does anyone have an idea? How many radians would that be?
Is it 2 pi?
It is 2 pi. That's right. Remember 1 pi. Okay, that's an M. That's not a pi. That's a problem. 1 pi is 180 degrees. So if we double that, 360 would be 2 pi. So that's 1 revolution. So if you don't have this in your notes, you might include that because they'll ask you questions about problems like this in degrees and in radians. So you should be able to ready to convert either of these. Okay, so if I plug my conversion rate in here, then I want radians on top. So I'm going to put the radians on top here. And I want revolutions on bottom, because if I set my problem up like this, see how I have a revolution in the top numerator and the denominator? Because of that, they'll cancel out, and the only units I'll have left are radians in the numerator and minutes in the denominator, like I want. If I go ahead and multiply my numbers now, 2,400 times 2 pi would be 4,800 pi. And in the denominator, 1 times 1 is 1. You could leave the answer like this. If you go ahead and actually multiply with the pi, you should get that is 1,500 or 15,079.645 radians per minute. So super fast. All right, does that make more sense now about how we do these problems? Or would you like to do another example?
I think it makes sense.
Sweet. Okay. Thank you, Lily, for helping me out there. All right. So before we can start solving problems with trig functions, we're going to, for this class, use a slightly different formula for like sine, cosine, and tangent that is easier once you get used to it, and will allow you to do sine, cosines, and tangents without a calculator. To do that, you first need to know what the unit circle is and why it matters. So the unit circle is a specific circle. It has a radius of 1, and its center is on the origin 0, 0. This is the equation for the unit circle, x squared plus y squared equals 1. And if you graph it, it looks like this. Again, center at the origin, radius of 1. So it passes through the points 1, 0, 0, 1, negative 1, and 0, negative 1. So I'll give you a second to write this down. And then we'll move on to the next slide. Okay. Does anyone need more time? All righty. Okay, this slide is intimidating. You don't need to write down everything. You can write down this. I suppose it's not really super important that you do. But you should take a picture of this. This reference chart can also be found. I don't know if you've seen this, but for your textbook, for the front page, in there is a resource sheet. The first front of that is geometric formulas. The second page is this is going to be a very useful page for you this semester, is a trig resource sheet. And in the top right, it has a copy of that. unit circle right there. What this unit circle does is it breaks down at different angles where that line or where that angle would intersect the unit circle. So at 30 degrees, this intersects the unit circle at square root of 3 over 2 and 1 over 2 for the y value. Why that's important is because what this angle really tells us is that this is from this angle, you can construct a right triangle where the opposite side of that angle is your y value, and the adjacent side of the rectangle is your x value. And the hypotenuse of that right triangle, because this is a unit circle, the radius, or the hypotenuse, is 1. So the x and y values here that's given to you are really the sides of a 30, 60, 90 triangle. If you remember back in geometry, there was 2 special triangles that Miss Waters would have talked to you about. The 30, 60, 90 and the 45, 45, 90, who have special ratios of their sides. The 30, 60, 90, the short edge is, if we say the short edge is x units long, then the hypotenuse is twice that, and the long leg is x square root of 3 times log. For a 45, 45, 90 triangle, the legs were the same length, and then the hypotenuse was x square root of 2, or square root of 2 times longer than the legs. And you could see, if we say that our hypotenuse is 1 for this triangle, then that would mean that x would be a half, which is why the y value of this side is a half. And the x value for this side would be square root of 3 times a half, or square root of 3 over 2. If we say the radius is 1 for a 45, 45, 90 triangle, then x would be 1 divided by the square root of 2, which is an issue because you can't have negative or radicals in the denominator. But if you fix that by multiplying by the square root of 2 over 2, you get the square root of 2 over the square root of 4, which is just 2. So for a 45, 45, 90 triangle, if you say the hypotenuse is 1, that means the side lengths x are square root of 2 over 2. And you can see that what they have right here. Why do I have so many people from second hour trying to join this class right now? So the long story short of this is the reason why I told you about this pattern and where these numbers come from is not necessarily important for our class, because for our class, all quizzes and tests, you could just look up what the numbers are supposed to be using a resource sheet or using the picture you just took. However, on the ACT test and on like the AP Calc test, where you aren't allowed those kind of resources, they expect you to have this representation here memorized. They expect to be able to say, all right, if you have an angle of 150 degrees, what are the X and Y values on the unit circle? And you'd be able to say from memory, negative square root of 3/2.5. That might seem a daunting task at first to be able to memorize this. Not a lot. On the ACT, the question was how many questions are like that? On the ACT, it's very possible that it won't be on there at all. It'd be a question that could show up in like the 45 to 60 range. And it wouldn't necessarily be phrased like that, but it would be like part of the answer requires you to know that. Or at least be able to find it, you know, like I did using my math, doing this math over here. On the AP Calc test, those are peppered in. Again, it's not a majority of the questions, but maybe up to a quarter of them would require you to use that at some point. Okay. Yeah, if you're taking the ACT this Saturday, that's probably not something you want to spend a lot of time on because it's not, again, you might use it on one question, if that. But it actually is not as daunting a task as it sounds to memorize this because there is a pattern to it. There are actually, in order to make this diagram, only 3 numbers you need to know. You need to memorize this one. At 30 degrees, the smallest angle, it's square root of 3/2.5. At 45, it's square root of 2/2. From those 3, you can create all the rest of this because the 60-degree angle, right, is just a 30-degree angle, 30, 60, 90, hold on, I don't want to do that. I want to do this. Right, this triangle is the same triangle as the 30-degree angle. It's just that the angles are switched. Now the 60's down here and the 30's up here. So you can see the only difference between this answer and that one is they're switched. And then if you can then figure out these 3, all the rest of these are the exact same, just with different signs, right? Like, for example, this one over here at 150 degrees. Well, if this is 150, then this is 30, right? So it's another 30, 60, 90 triangle. The answers will be the same. It's just since we're flipped over the y-axis, the x values are now negative. Same thing for all the ones down here. The only difference between my answers up here and my answers down here is because I'm flipped over the x-axis, the y values are now negative. So all you really need to be able to do to recreate this unit circle is know the answers for the 30-degree triangle and the 45-degree triangle. And from that, you can build the 60 and all the ones on the second quadrant and the third quadrant and the fourth quadrant. See? By the end of this semester, you'll have these, I won't say completely memorized, but at least a lot better than you were at the beginning of the semester because you have done so many. All right, any questions about this? All right, the last thing we need to do is we're going to shift gears a little bit. Now let's talk about trig functions. And then we're going to marry the 2 concepts of how you can use the unit circle to find the answer to trig functions. So as a quick review, this should be, you should already have seen this before. There are 3 basic trig functions, which you can remember with the acronym SOH, CAH, TOH, AH. They are sine, cosine, and tangent. The sine, abbreviated SIN, of an angle is supposed to tell you the ratio between the opposite side and the hypotenuse. The cosine of an angle is supposed to tell you the ratio of the length of the adjacent side over the length of the hypotenuse. And the tangent of an angle is supposed to tell you the ratio of the opposite over the adjacent. SOH, CAH, TOA. So, God, toa. So this, hopefully, you've seen before. This, I think, is new. I'm not sure. I'm pretty sure it's new. There are actually 6 trig functions, not just 3. There are 3 more which are called your reciprocal trig functions. And they're actually not that bad at all. They are cosecant, secant, and cotangent. They are called the reciprocal trig functions because they are functionally the same thing as sine, cosine, and tangent, just flipped. So cosecant of theta is supposed to give us, instead of opposite over hypotenuse, it's going to be 1 over sine. So it'll be hypotenuse over opposite. It just flips it. The secant of an angle is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Cotangent of an angle is the reciprocal of tangent. It's 1 over tangent. So instead of doing opposite over adjacent, it does adjacent over opposite. So if you know what sine is, you know what cosecant is. If you know what cosine is, you know what secant is. And if you know what tangent is, you know what cotangent is. It's just your answer flipped. All right, does anyone need more time to write this down? Okay. All right, let's put the 2 concepts together. You don't need to write this. You absolutely need to write this. This is the most important thing you'll write today. So again, this is what was just on that previous slide. The sine of an angle is supposed to give you the opposite over the hypotenuse. Cosine adjacent over hypotenuse. Tangent is opposite over adjacent. If you construct for any angle theta, that angle in your unit circle, it will make a right triangle where it intersects the unit circle. And what's amazing or great about that is because this is in the unit circle, the hypotenuse will be 1 because the unit circle has a radius of 1. No matter where the angle is, right, wherever it intersects the circle, the hypotenuse will be 1. And so if you substitute that in for h in your formula here, then the sine of your angle becomes the opposite over 1. But anything divided by 1 is just itself. So then the sine of your angle just becomes the length of the opposite side. So the sine of your angle becomes the y value of this point right here. Similarly with cosine, if you plug in 1 for h, you get a over 1, which is just a. So the length of the adjacent side is the exact same thing as the cosine of your angle, which is just the x value of this point. So then for any real number t, for any angle that you could draw, then the x and y values that angle intersects on the unit circle gives you the answer to your trig function. The sine of that angle is just the y value of your point. The cosine of the angle is just the x value of your point. And then the tangent of the angle is opposite over adjacent, so it's the y over the x. And then for our reciprocal functions, remember that's just the reciprocal of our previous answers. So cosecant is just 1 over sine, so it's 1 over y. Secant would be, instead of x over 1, it'd be 1 over x. And cotangent of that angle would be, instead of y over x, it becomes x over y. All right, so that was a long lecture to get to these 6 formulas. Once you have these 6 formulas down, it actually becomes fairly easy then to find the trig, your trig answers at different angles using these formulas and that reference chart that you should have a picture of. Does anyone need more time to write down the formulas? Okay, and let me show you how to use them. They're not that bad. Now this is what we'll end class on today. So if we want to find the 6 trig functions when our real number is the angle pi over 6, we could do that fairly quickly, actually. So we need to find the sine of pi over 6, the cosine of pi over 6, the tangent of pi over 6, the cosecant of pi over 6, the secant of pi over 6, and the cotangent of pi over 6. All right, so the first thing that you'll do is you'll find this angle in that unit circle. So if you look at your unit circle, oh, that's not what I want. Oh gosh, roughly like that. You should find that pi over 6 is this first angle. It's the same as 30 degrees. And the coordinates of that point are square root of 3 over 2 and a half. All right, that kind of got cut off there. I'm going to cut it. Square root of 3 over 2 and a half. That's your x and y values that correspond with the angle pi over 6. All right, so once you have found that angle in your reference sheet, you then use your formulas to write your 6 answers. The sine of t is supposed to be the y value, so it's a half. The cosine of t is supposed to be your x value, so it's square root of 3 over 2. The tangent of your angle t is supposed to be y over x, so it'll be a half over the square root of 3 over 2, but that is not an appropriate answer, right? It's got a fraction within a fraction. So if we fix that by multiplying by 2, you'll get 1 over the square root of 3. Okay, when you're doing these on WebAssign will actually accept this as an answer. To be honest, it really shouldn't accept this as an answer because, like we talked about earlier, this is not appropriate. It has a radical in the denominator. That's a no-no. So really, you should fix it by multiplying by the square root of 3. And that'll leave you with the final answer of square root of 3 over the square root of 9. But the square root of 9 is just 3. And now your answer doesn't have a radical in the denominator. All right, and then getting these answers is actually super easy. You just take these answers and flip them. So 1 over 2 becomes 2 over 1, which is just 2. Square root of 3 over 2 becomes 2 over the square root of 3. And again, WebAssign will accept that, but really it shouldn't, and it won't be, like on the ACT, that's not going to be listed as an answer. You'll need to multiply by the square root of 3 first to get 2 square roots of 3 over 3. Now, when you're doing cotangent, you might be tempted to flip this one, but that's going to put a radical in the denominator. You should flip the original answer you got, and you'll do square root of 3 over 1, which is just the square root of 3. And if you flipped this one and then rationalized it, you're going to end up with that answer anyway. So there you go. We just found the sine, cosine, tangent, cosecant, secant, and cotangent of pi over 6 without using our calculator. Isn't that great? All right. Any questions about what just happened? Again, the steps we did was find the angle on your unit circle sheet, and then used our formulas, plus simplifying some stuff. You find the angle that they give you on the unit circle, find its xy value, and then you use your formulas to get your 6 answers.